Okay, for class today, we are going to now have people show their expertise at solving problems. And I want to go through and assign who's going to do which problem
Wait.
at the beginning.
I thought it was due next week.
Right. So remember, today is when you are demonstrating solving one problem, and then you have the time between now and next week.
Oh my.
You saying you didn't do it?
I did it.
Oh, bad times.
Well, we can.
Well, let's start here at the bottom.
We can attempt.
Who feels that they are able to do the integral of 10 natural log of 4t squared? And it is the hardest one, mind you.
I have a question.
Yes, Gita.
Do I have to use UV minus the integral of VDU?
To do this one?
Integration by parts?
Yes. Integration by parts is how that one's done.
Okay.
So that's all.
Just want to make sure.
As long as the integration by parts is how you do it, then sure. Okay. Actually, I'll write it on this one. What about the one up above that, the 7t? Actually, yeah, it's this one here that I had to do integration by parts, not this one. This one here I didn't have to do integration by parts. But no, I think I did. You're right. Because natural log. Okay, how about the one above that, the D? Who is up for that?
The worksheet I have. Oh, never mind.
That one definitely has to be done by integration by parts. No one?
I have a question.
You have a question about it?
Yeah.
Okay, what's
Would it
that?
have worked using an integration table?
Not for this one. Okay, well, let's go to C. Okay, Alex. B. Cole was first. A. Corso. And then,
But we started from the bottom, yeah?
yeah, we started with the bottom. So those are all the integrals. Now doing derivatives for the same set. Who's left? 1, 2, 3, 4.
So we just take the
So-
same problem again.
Ashley and Trace.
Yeah.
Either one of you for this one?
E?
Yeah, derivative. Okay.
I just don't know how well else is going to go for either of them, but I can take one, I guess.
Well, you're going to have to take one, and after we get you and Trace, then I'll let other people do a second one. You'll get a little extra credit on the assignment for doing
Okay.
the demonstration or the.
I can attempt E. I can't promise anything.
Okay, I'll take the one.
Okay, so I'll put it on Ashley. What about D? Well, I want to get Trace on one first, and then. Okay, can you do D, Trace?
I can once again. I can attempt. I can't.
Okay, well, tell me what you feel comfortable with, Trace.
I can probably do A, to be honest. I know
Okay, A I've already done. A is my demonstration.
I can attempt to do C.
Okay. Okay, now for the people who've done an integral, do any of you want to do D? Okay, Gila. And any of you who've already done an integral want to choose B? Okay, Alex. Okay, so now we have people assigned for each one, and we'll go through, and apparently Richard will do that one. So a couple, Alex and Gila, will get a chance for twice the extra credit of everyone else. And I will be actually grading your work on it. So like if you do it completely wrong, you won't get much extra credit. But if you do it completely right, you'll get basically like an extra problem's worth of credit. So what the solution should look like, I don't know if this is going to work. Oh, great. Look, the pin Shino work now. It's a brand new battery. It was working just before class, but it was too sensitive. So I had to take the battery out for 10 seconds to reset it, and then it worked. Let us pray, since it's a brand new battery, that's not the problem, that it will work now. And yes, I say battery. It's because of Eddie Murphy. Okay, so your solutions just for this assignment, because I want to see that you understand the steps, should be very explicit like I showed here. So I have df dt is equal to, and you see I brought down the exponent 2, and then I have the 5t raised to the, and 2 minus 1, because I'm lowering the exponent by 1 for polynomial, minus, bring down the 1, 20t to the 1 minus 1, and then plus 0 times 17t to the 0 minus 1. How many people knew the derivative of a constant is 0 times 1 over? Yeah, nobody ever says that. It's just constant. But that's what the polynomial rule would tell you. You don't have to put this in there because that's kind of silly, right? You could just put the 0. And then I simplified it. So that's how your solution should be. So let's get on with this game. So let's go to Alex. Do number 2. So come on up here, and you will just right away, I will change your pen color for you to purple.
Do I need to be talking while doing it? Probably explaining what I'm doing? Okay.
It's going to be recorded for posterity.
All right. So I'm going to change f of t equals 6 over t squared to f of t equals 6 times t to the negative second to make the power rule easier. And then I'm just going to do the power rule. It'll be 6 times negative 2. If I'm doing this right. Times t to the negative 2 plus 1. Which means it should be, let's see, am I doing that right? Negative 12 times t to the negative first, which means it should be negative 12 over t.
He made one small mistake. One
Yeah.
mistake.
That 12.
12 is right.
It should be minus 1.
Oh, right.
I didn't hear what she said.
She said it should be minus 1. I was
Yes,
doing
that's
integrals
correct.
just a second
That's
ago, so I got it wrong. So the negative third, so to the third, and so this should be
And if you press the lower button, it's the eraser.
interesting. And do I need to hold it?
Yeah.
Lower, meaning closer to the
Yeah.
front.
Sorry, going closer to the tip. Okay, there we go. So, and put a circle around your answer. And just to make it more readable, put like df dt equals before the 6 when you started the derivative.
Which one? The second?
It's the second 6 when you started the derivative. Before that, put df dt equals. And then just put it equal before each succeeding one. So before the minus 12, put it equal. And then before the last one, put it equal. It's understood that the original thing before the equal comes before each one of those.
Okay.
Okay, so that's correct. Thank you, Alex. Next would be Trace. And you scroll just using one finger to scroll up and down. If anyone has questions, ask away. This is on OneNote, so if you can get access to OneNote, you'll be able to look at this, and of course you'll also be able to listen to it on YouTube.
Okay, so
The other one you're doing is integral C.
so can I ask a question? E is the derivative of E is ln, right?
No.
No. Okay.
It's just The inverse function of e is ln.
Okay, so e is just e.
Yeah.
3 to the t. Oh my gosh, this is so tough to do.
You can change the angle if you like. You can take down, kickstand, make it flat, whatever.
Okay, I might do that.
The reason I put it like that is because the sound is very muffled if you keep it flat.
I'll leave it then.
You can flatten it at least. Just push down and it'll flatten.
Okay, so then e is just e. 3t is going to be. It's going to be t squared. No.
Okay. To help them out a little, when you have an exponential, you take the derivative of the exponential. You have it's actually really, really simple. But of course, if you don't know the rule, then it's not,
Yeah.
right? So the rule is it's the derivative of the exponent.
Okay.
So you have 24 times, and what's the derivative of 3t?
I'm just blanking.
Just 3t, nothing special.
Oh, it's just 3t?
No, I mean the derivative of just 3t.
Oh, just the derivative of 3t is t squared. No, I'm thinking integral, aren't I? Somewhat.
Well, the integral of t is 1/2 t squared. But
Okay.
the derivative of 3t, you have, what's the power of t if it's 3t? T raised to,
3?
no, t by itself is
Okay.
t raised to 1.
Okay, yeah.
Right?
He's telling you the derivative.
Oh, yeah, okay, yes, 3 is the derivative.
Okay,
Right. Okay. So the derivative of 3t is just 3.
yeah. Okay.
And so you're going to bring down the 3. So you're going to have 24 times 3.
No, 24 times 3. This is the erase button? Okay. 24, okay, whatever. I'm just going to erase that entire bit.
So let's actually, since you're starting over, let's put df dt
Okay.
equals, because that indicates we're doing our derivative now. So we have 24 and then
Times.
times 3.
Yeah.
And then you have the entire exponential you started with.
So the e to the 3t.
Yeah.
And that's just e.
No, the entire thing, e raised
Oh,
to 3t.
E raised
You
to
keep
3t.
the same
Okay.
exponent. So you bring down the derivative of the exponent and then you have the original. And of course, the last step equals,
Yeah. What's 24 times 3 is 48. 72? Okay. Okay.
and that is a 3, right?
Yeah, I have bad handwriting and I'm left-handed, so this is becoming a bit more difficult. Okay.
All right. Everybody understand that? The point of this one was just to make sure we can do it exponential. Now, Gila is going to give us a more advanced version.
Ooh, fancy. Oop. So first off, I changed this to 7t e to the 20t because of power rule.
Everybody understand that? I wanted to make sure people understood the simplification there, that e to the 5t all raised to the 4th, you just multiply the exponent, so e to the 20t.
And then I'm using the what's a multiplication rule?
But the
Oh,
same
wrong
first
one.
time.
Sorry.
Yeah, product rule.
Product rule, where A is 7t and B is e to the 20t, and then sorry. There you go. And then taking the derivative of A, you get A prime, which is 7, and then the derivative of e to the 20t is 20 e to the 20t. And then you put it together. Nope, I ran out of room. Like that.
Yeah, I say put a box around just so we can, not make sure we're not, yeah, there we go.
140 TE.
Okay, that's about as perfectly as it could be done. Any questions for Gila? All right.
Okay, so it's to the e to the 20t.
All right, and the last of the derivatives, actually wrong.
I've only taken the top one.
I knew I had it spelled wrong.
Okay. So I'm forgetting what to do within like the parentheses.
Okay. I'm just laughing because I noticed that down below where I put my limits,
Uh-huh.
I shifted things down and my limits didn't shift. Okay, so you're forgetting what to do with,
So because the 4t is multiplied together, but but the t is also squared. I guess it's everything squared. So
no, only the t is squared.
Only-
4 is not.
okay. So, right, that makes sense. Sure. So based on this, would I do 10 multiplied by the t squared?
Well,
Or the-
there are two ways to approach this. One is to use a U substitution, to use the chain rule, and one is to simplify it first.
Okay.
So you have to choose one of those two approaches.
I think I should simplify first.
Okay.
Would make
So
it
how can
easier.
we simplify 10 natural log of 4t squared?
10 to the e, or I'm not sure. It's
The natural log of, we have things multiplied together. If we have natural log of a times b,
mhm,
how can we separate that into two separate terms?
like natural log of a like plus natural log of b.
That's right. So what we have there is natural log of 4, a constant,
Mm-hmm.
and then t squared, something has our variable.
Mm-hmm.
So we can separate that, and so we would have
Natural
10
log.
times natural log of 4 plus
Oh.
10 times,
Well, I mean, if it's a constant, wouldn't it just be 0?
after we do the derivative, yes.
Okay.
But first we're simplifying before we do the derivative.
All right. I don't know how to erase, so I'm just gonna do that. Click on.
The button closer to the tip of the pen gives you the eraser.
Oh. Gotcha.
It's okay. You hold it.
Yeah, you have to hold it. It's only eraser while you're holding that button.
Okay, gotcha. All right. So the
That natural log of 4, not just 4.
Right.
It should be 10 times natural log of 4.
10 times that. Okay.
And then we have plus. Now for our second term, notice we had t squared.
Mm-hmm.
Well, t squared is t times t.
Mm-hmm.
And so we could, let's not write this down, but we could put 10 natural log of t plus 10 natural log of t. But we can all in our head say 10 natural log of t plus 10 natural log of t turns out to be 20 natural log of t. So the other rule we learn is if we have something raised to a power, so this is t squared, we bring out the power. And so it's going to be plus 20 natural log of t. So that's our f of t, is that function you just written. So now if you take the derivative of that function, then what do you have?
Like,
So let's start with either df dt or f prime.
okay. F. I don't know. All of them seem like constants. Like,
Well, the first one, 10 natural log of 4, is
it's
constant.
constant. Yeah.
So it's derivative of constant.
0.
Okay, so let's write that in. 0 plus. And then we have 20 natural log of t. Natural log of t, that's not a constant. So what's the derivative of natural log of t?
Be like t to the power of like 20 or 19.
Derivative of natural log of t. Anyone else? It's 1 over t.
Okay.
So it's going to be 20 times derivative of natural log of t is 1 over t. So 20 over t. And we're done.
Okay. Yeah. It's been a long summer. Need to refresh.
All right, now to the integrals. Your paper has it shown right. My work up there has the limits funky. But we're doing integrals with limits. And yes, of course so. You get to do the first one.
So wait, what are the limits then?
The limits are going to go from 0 is the lower limit to t final is the upper.
So you're gonna do integrate final.
The
And-
t was funny in the f of t, but it
Okay.
was surprisingly like an x.
Yeah. And we're gonna put in the function.
Yeah.
That's given. F of t. I see what you're saying. It would be f0.
Notice what he has written here is perfect. You have to have those parentheses. If you don't, you have mathematical nonsense. You have to have the dt at the end. If you don't, there are some textbooks they made that said, oh, that just confuses people, let's not put the dt there. But you need to indicate what your variable of integration is, plus it actually represents something. It represents a very small amount of time. If you don't have it, your units are wrong. Okay, go ahead.
Now we're gonna go ahead and integrate. And it's gonna be for this one you take the 5 and then t squared, it would be t is second plus 1 over 2 plus 1. And then I don't know if I should close the parentheses, but
I just keep going.
all right, 20. And then we do the same thing. T 1 plus 1 over 1 plus 1 plus 17 t 0 plus 1 over 0 plus 1. And then you can
You can
just
slide over.
okay.
It is nice. You don't run out of space on your line ever. It's infinite.
And
I
then
should use a square since you have square on the other side, just to match.
oh yeah.
Oh wait, you have both. You have both.
Yeah, I'll close that and then do that.
There you go.
And then TF 0.
Okay. Now everyone may not be familiar with this. I don't know. So notice he's indicated his limits there on the bracket. So now he's going to put the limit in.
Yeah. Oh, first I was gonna simplify. Right. It would be this one would be 5t to the third over 3, so it would be 5 third, and to t to the third, and minus this one would be 20. We got 2 at the bottom, so it would be 10 t squared, and then this one would be 17t over 1, 17t. We can just go ahead and add the f's in front of the t.
After. Why can you do that?
Huh?
Why can you do that?
Because there's 0 there, and
Okay, so when you put in 0, you're going to have all the rest of the terms 0. I'll let you do that because you are already running into the space of the next problem.
yeah,
Normally, I'd say I want you to write
yeah,
5 thirds t final cubed minus 5 thirds 0 cubed.
yeah.
But
I
because
know
of that
that.
space.
Yeah.
I'll let you do that.
All right. That should be the final answer, but there is a step missing. If this number wasn't 0, if it was any number, we can go ahead and subtract and finish it.
Okay. All right, Cole.
Yes.
Oh boy. All right. Actually, I think I can put in more space. We'll see if it works.
That'd be good. I don't know how small I can write.
Yeah, I can't write small.
Yeah.
I thought I was.
I would say every time you
Okay, look. I put in space. Yeah, that'll work.
page and a half, I'm like,
So yeah, you got tons of space now.
Cool. So I just write on it like a regular
Here.
pen.
Let's be fun. Let's change your color. You're being red.
Red. Okay. So whoa. Okay. So we'll start. Do you want me to just do because I usually solve it for the indefinite integral first, or should I just solve it straight up for the?
Well, don't put a plus C if that's what you're saying.
Gotcha. Okay. Or you know what? I think I can probably just do it. So T. Oh wait, whoops. That's not what I wanted to do. It's the lowest button to erase?
Yes.
Okay. Okay. And then I just put the arrow here to signify that like I'm moving down. So first I'm going to take out the constant 6. And I'm just simplifying right now. Actually, I can make this smaller. Then we can apply power rule. Oh, sorry. I always write X as a force of habit here.
You also don't have the integral sign anymore. You just evaluate the integrals.
Oh, okay.
So you race back to the 6.
Yeah. Try to make that look more like a 2. So that's our indefinite integral. Since we're not putting the plus C there at the end, I can take the limits, right? From
Let's do that's a T.
Oh, right. Shoot.
As Corso did on the line before, you should indicate your limits.
Yeah.
Oh, right here, like with the brackets.
Yeah.
Okay.
Now here's the part where a lot of students make a mistake. A lot of them get to here, next step, is where this goes.
Wonderful. Great. I'm so excited.
In case he makes a mistake, that everybody just say, "Oh, Cole."
Yeah. It's okay. I didn't expect to make it this far. Okay, I have to make sure I don't write an X here. Actually, there. Oh. So this be 6. 0. And this is like, you can't do this, right? Because it's undefined, so we'll just stop there.
Yeah.
So is it just minus 6 over t final?
For the final answer?
Yes.
No.
Uh-oh.
What you've done is all correct. And so what you have for your final answer, if you want to write this out, your final answer would be minus 6 over t final plus undefined. But that's like saying my bank account is $6 plus undefined.
Right.
Do I
Okay.
know how much I have in my bank account?
Yes.
No.
No?
If it's
Yeah,
undefined, if it's
because-
plus undefined, I still don't know what it is.
Oh, okay.
So the total answer is undefined because part of it's undefined.
So how do you write that?
UNDEF.
Oh, okay.
Oh, you can just basically like. Okay. One part is
Yeah, one part's undefined, the whole thing's undefined.
Okay, cool.
And you see where people mess up on that part.
Yes, I was a little confused.
Those limits, that's L'Hopital.
No. No, L'Hopital's rule is what you use when you have 0 over 0 or infinity over infinity.
Okay.
Okay, next is Alex.
Alexander.
Back for round 2.
How did you stretch it?
Okay, so right next to the pencil eraser, there's that thing, yeah. And then just, yeah.
Did it work?
Yeah, it worked.
It worked. Okay. So let's see. I need to.
It does not work if you're in the middle of a PDF, but I put this one in so it works.
I'm going to try to make this actually look like a 0. Okay. Integrate from 0 to TF. T. Then I'm going to move the constant out.
You forgot something in that line.
Right. Parentheses and DT.
Didn't need parentheses because there's no plus or minus, but you needed
Okay.
PT.
All right. 0 to e to the 3t dt. And I'm not sure the exact power rule to this, but I know that the f dt of let's see of
I'll show it for you, Alex.
Mhm.
Just the derivative of e to the 3t was
Right.
down the derivative of the 3.
right.
So when you do the integral, you divide by.
Right. I just wanted to figure out. I knew I needed to divide by 3 and just do that, but I wanted to know how to do that explicitly.
All I have for the explicit is your divide by the derivative of the exponent.
Awesome. Okay, so 24 times 1/3 e to the 3t from 0 to tf. And so then I can simplify that to, yeah, because I really can just put the 24 in there, right?
Well, yeah, 24 times.
Right, because I'd rather do the 8. So 8 e to the 3tf minus 8 e to the 3 times 0 means that it equals 8 e to the 3tf minus 8.
Yes. And once again, this one, a lot of people make the mistake of just putting 0 for the second term because they're thinking, well, I put in 0, so it's 0. You know, I let Corso just say that with his because they were all polynomials. But with the exponential, putting in the 0 doesn't give you 0. Good job. Okay, next is Richard. So for mine, notice I gave it more space. I will once again immediately expand this to
I didn't figure out which problem used the local column. So.
it's the last one.
Okay.
7t to the 20t. So now I need to do the integral of that. And the only way to do this integral is by using the integration by parts. I probably just need to spread that out. So integration by parts is when you have an integral that you break down into a u and a dv. So you break it into two pieces, and you need to choose those pieces. So when you take the derivative of u, it gives you something that's going to make it simpler for doing the integral. And of course, you have to take the integral of dv. So in this case, I look at it and I say, well, this is set up easy for me. If I make 7t my u and e to the 20t dt my v, or that's dv, excuse me, then life is kind of easy. U is equal to 7t, so du is equal to 7 dt. dv is equal to e to the 20t dt. So if I integrate that, just like Alex had to do, I'm going to have v is equal to e to the 20t over 20. And so I'm going to put these blues and greens into my integration by parts equation. And so my integral is going to be equal to u times v, so that's going to be 7t multiplied by e to the 20t over 20. Going to have my limits from 0 to t final on that, minus the integral from 0 to t final of my v, which is e to the 20t over t, or not over t over 20, that would have been a big mistake, multiplied by my, and I'm going to actually be consistent with colors. Let's do that. And then multiply it by my du, which was 7 dt. So I still have to work this second integral. The first one I just have to put in the limits. So I'm going to work the second integral and then put it all together. So working that second integral.
How is it different from the first? I mean, well, we did use substitution. for your 7dt.
I didn't catch what you said. How does what work?
I was just trying to think about why they were different, but we did the U substitution.
Right. So that's why I put it into the blue for the DV part and the green for the blue for the V and the green for the DU.
Okay, so what's the first part done then?
The U times V, I haven't applied the limits yet, but that's going to be correct. I'm going to expand this out so I have the limits for the rest of it. So the 7 over 20 is going to stay the way it is. But when I integrate e to the 20t dt, I've already done that once. I did it in my head down here. It's going to be e to the 20t over 20. And now I just have to put my limits in. So putting in the limits, notice 7 over 400. We all figured that one out, right? So I have 7t final e to the 20t final over 20. And I'm going to do both limits on the first one, then both limits on the second one. So the upper limit minus the lower limit, 7 times 0 e to the 0 over 20. 7 times 0 e to the 0 is 0. Minus 7 over 400 e to the 20 t final plus 7 over 400 e to the 0. 7 e to the 0 is 1. And so my final answer is there. Now you can arrange it lots of different ways. I chose to factor out the e to the 20tf, but not to factor out the 7 or over 20. Right? You can choose different ways of writing it out. Any questions about how I did the integration by parts there? How many people were familiar / comfortable with the integration by parts? Okay, so we got at least 3 partials. Last one, Gila. You've got the whole rest of the page. I don't remember. I'd have to work it out again.
Okay. That's okay. But I didn't do L'Hopital, so who knows where this is going to go.
Okay.
Can I? No, I don't want to break it. So first please don't move. I did the power rule. Oh, let's see. I did 10 times 2. Okay.
You could have said it down there.
Sorry. Okay, and then I put it in an integral.
Okay. That's not quite right. You could
Is
put
it
a
not?
2t in there and it would be right.
Shoot. Okay, wait.
Because it's the 4 wasn't squared, but 4 is 2 squared. So if you put natural log of 2t, it will be correct.
What? Wait. Wait, repeat.
Okay,
Please.
so if you look at the first one, it's 4 times t squared. The 4
Right.
was not squared.
Right.
Your expansion was as if the 4 was squared.
Oh,
So it would
Yeah.
still be fine if you changed the 4t squared to parentheses 2t
2.
and parentheses squared.
I got you. So this is technically 2 squared. Whatever. It's doing weird
That
things.
was me.
2 squared. So then I could do 2t then.
Well,
No.
if you just change where you have natural log of 4t, if you change that to a 2t, it's going to be correct.
Oh, okay, that makes sense. Getting it. Oops. Okay. And now I can put it here. I'll probably use the natural log. Okay. I did a bunch of U subs. Is that okay?
Do what you need to do.
Okay. So I did. Well, yeah. Which means I have to multiply by 2 and divide by 2 to get this. But and then for this one, I used the UV BDU thing somehow, where yeah, where U is natural log of x and V is dt, and then du is 1 over x, and V is x, or dt. D. I did something weird. Wait. Yeah. No. My notation is off, but I don't know where. And then I did natural log of x times x minus the square root of v, which is that dx. And then minus or x. Oh, okay. But then x equaled something. Oh shoot, I lost it. Where x equaled, or u, that's what it is. Technically, it's like 14, right? No. Wait. Oh, that's right. Um,
We're actually 2 minutes over time. So I'm
I
going
lost it.
to take it out. This one here, we're not finished. She is making good progress, but I need to point out the L'Hopital's rule. You have to use L'Hopital's rule in this one. What you're going to get here, the term that she has written here, now it depends on how you work it, what exactly it's going to be. In my working that I just did, remember, she wanted me to check to see if she's right. I'm like, well, I have to do it. So I did it while she was doing it. You have 20t natural log of t, the way I had. So, I mean, she has a different factor up front. And then you have the limits from 0 to t final. Well, when you put in t final, it's not a problem. That's going to be 20 t final natural log of t final. But then when you put in the lower limit, the limit as t approaches 0, because we call them limits because that's what you do. You put in the limit of 20t natural log of t, you have yourself a conundrum. Because when you put in 0 for t, that's going to be 20 times 0 times, what's natural log of 0? Minus infinity. 0 times minus infinity, because it's a limit, could be anything. So as you look at that, you're like, well, that's indeterminate. It's not undefined, it's indeterminate. And so if it's indeterminate, we have our ways of determining what its value is. But to do that, we have to use L'Hopital's rule. So L'Hopital, it's either written like this or like this. I tried to put that carré over the O, and I'm sure that's now in the wrong place. L'Hopital's rule says that if you have the limit, x approaches something, where this a over b is approaching 0 over 0 or infinity over infinity, then you take the derivative of the top, the derivative of the bottom, and try again. And so in this case, you look at it and you're like, I don't even have a fraction. But 20t, well, t is the same as 1 over t. And so what we're going to do this is write the limit, bring the 20 out here. I don't need that in my work. As t approaches 0 of natural log of 0 of t divided by 1 over t is equal to 20 times the limit as t approaches 0 of the derivative of the top. What's the derivative of natural log of t? 1 over t. And the derivative of the bottom, what's the derivative of 1 over t? It's minus 1 over t squared. Well, that second one, now this is determinate. That's going to be 20 times the limit as t approaches 0 of minus t. And so in the end, it turns out that that last term is 0. But you have to use L'Hopital's rule to determine that it's 0. It was indeterminate if you just started out and didn't do L'Hopital's rule. So that's the trickiest part of this last problem. And so everyone who has access to OneNote can now see that portion. All right, we are late. Everyone but Alex is excused.